Hello, everyone. Welcome to BiogasWorld's US month webinar discussing the opportunities and challenges of the American biogas market. As a reminder, this webinar is being recorded and will be shared with participants following the webinar. In addition, if you have any questions for our presenters, we invite you to write them in the chat, and we will ask our presenters following their presentations or in the Q&A at the end of the webinar. BiogasWorld hosts a new country-focused webinar each month to discuss the opportunities and challenges within various markets. Be sure to also join us on our biogas community website for the latest updates and to network with companies in the biogas and RNG industry. I would like to thank our presenters for joining us today. Jeff VanVoorhis, Vice President, EPC Project Development with Mead&Hunt. Kim Murdock-Timmerman, Aftermarket Sales and Service Manager with Unison Solutions. And Scott McKay, Business Development Advisor with Fournier. Our presenters bring us a diverse range of perspectives on the US market. Mead&Hunt are an EPC working on biogas and RNG projects. Unison Solutions are a US-based upgrading and biogas pretreatment equipment supplier with an extensive portfolio within the market. And Fournier are a Canadian company actively conducting business development within the US. Before we begin our presentations, I'll take just a moment to share some insights from the American biogas and RNG market. So looking left, we see some numbers from the American Biogas Council showing that there are approximately 2,300 biogas facilities across the US, almost half of which are located at wastewater treatment facilities. Landfills and agricultural facilities account for around the other half, with a growing number of commercial and municipal food waste digesters coming up. Looking over to the right to how biogas is utilized in the United States, we see a little over half of facilities are utilizing biogas directly for heat or simply flaring it. Combined heat and power engines account for approximately a third of facilities, and the remainder are RNG. Larger projects with a higher potential gas output are looking to transition from flares or CHP to RNG to take advantage of transportation fuel credit markets, which add a valuable source of revenue for projects. However, flares are still considered at small sites where upgrading or CHP might not be feasible. Moving towards development, on the left, we see the most significant growth for new agricultural facilities. This upward growth trend is likely to increase in coming years as the US begins to realize its enormous agricultural biogas potential. Landfills account for the next quarter of new development. However, this type of facility is likely to decline in coming years as municipalities and companies move towards anaerobic digesters to dispose of organic wastes. Commercial, municipal, and wastewater treatment plant projects account for the remainder of facilities in development. Other in the graph represent second-generation facilities, for example, those processing woody biomass. On the right, we've divided the US development into subregions, separating the two largest state markets, California and Texas, which account for a third of new development. The Midwest is the next largest region with about 79 new facilities in development, followed by the South with around 56. So thanks for your attention with this. So we'll now move to our presentations. Our first presenter is Jeff VanVoorhis, Vice President, EPC Project Development with Mead&Hunt. Jeff leads turnkey project development across all industries by using the engineering, procurement, and construction alternative delivery method. He is a trusted, responsive, and innovative advisor who travels to project locations to develop relationships, learn client needs, and identify solutions, including opportunities for funding. Jeff enjoys all water and snow sports, and when not on a project site, you will find him on a lake or mountain with family and friends. Jeff, I'll pass that over to you.
All right. Thanks for the intro, Ryan. I will share my screen. Is that sharing, Ryan?
Yep.
All right. Sounds great. Well, thanks for the intro. Like Ryan mentioned, we're an EPC firm, so engineer-led general contracting firm, so we can provide the engineering, the procurement, and construction. And I'm going to share with you real life experience. So we've done biogas projects with a volume of 105 projects to date, with a wide range of locations. And I'd say the split is about 50-50 for landfill biogas versus digester biogas, with the digesters being a variety of substrates or commingling of substrates within that portfolio. So drawing upon a broad base of completed work. And I think Ryan mentioned there's a significant number of projects in development, and that's what I was hoping to share with you a bit today on the development side of the projects from an EPC's perspective. And what makes us unique as a company when we talk about this and why we've been able to complete so many projects is we have that engineering process, in-house knowledge where we can work with, obviously, with vendors and equipment vendors like Kim and in her presentation to follow, and then executing the project as a contractor, a fabricator, and a commissioning company to see the project all the way through to completion, understanding all the nuances that come through that entire cradle to grave, so to speak, process of project development and execution is what we can draw upon with over 100 projects. So we put together a trusted and proven phase gate process for developing these projects. And this is what it looks like from an EPC. And you can see each column represents pretty much like a milestone for us and what we're doing in each one of those milestones. And it's really helping drive the project forward versus a traditional design, then go out for bid and then go for build. We're compressing that overall schedule substantially by using these milestones, but yet we're trying to de-risk the project by getting adequate information to all the parties involved, such as permitting, such as financing, and then us on the execution side. And one of the challenges I think that Ryan had asked me about that we're seeing right now is the funding mechanisms for these projects, particularly the IRA and the safe harbor associated with the IRA tax credit getting into construction by the end of this year, or having the percent spend by the end of the year. So when we look at that requires this schedule to compress even further, especially if we're just starting like in June and trying to meet those deadlines. We're compressing the schedule even further to do that. So how are we doing that? Let me just show you a quick graphical representation of what we're doing. We're really doing this by getting into construction or procurement of a couple key components. So what we're doing is we're identifying very early on what are the long lead pieces of equipment and what are the substantial pieces of equipment from a capital perspective that could meet that threshold spend for the IRA safe harbor. So once we've identified those, then it's getting contract terms in place, T's and C's, getting that equipment ordered and getting all the proper documentation that we would use to submit with the IRA. Because remember, the IRA is a tax credit. So just remember, when you pay your personal taxes, it's not that far off. You need receipts to show what you've been purchasing. So it's the same type of thing we'd be doing as the EPC to stay in compliance with the regulatory requirements for the IRS and that tax credit. So we are expediting that equipment procurement so we can make those purchases by the end of the year and making it very clear what needs to be done for that procurement timeline. So we're really shifting our focus a bit from design to procurement, which is abnormal for a typical project. We'd be focusing on design. Here we're shifting it to procurement of those key items very early on in the project. We also may be looking at what could we do to start construction as well. Some entities are requiring us to recover both sides of the safe harbor by doing the percent spend and getting into construction to cover their bases in regards to that tax credit. So we're also pulling some of that upfront work that's eligible under the tax credit for construction as well. So we're maybe looking at a different construction sequence to keep the project moving construction to meet that tax credit hurdle. So that's what we're doing in it, making a what we would say is a conventional EPC project even less traditional by trying to meet this expedited schedule. And we've got lots of projects we're doing right now successfully that we can pull from and show examples to other entities in this similar stage of development and how you can successfully meet these deadlines. So that's what I had to present today. I appreciate the time, Ryan, and I'll take any questions at the appropriate time.
Thanks, Jeff. There doesn't seem to be any from the audience quite yet, so I will ask you then, so what is the best thing a project developer can do to de-risk a project prior to the EPC contract?
So it's getting alignment with all the entities. So what we would typically provide is a roles matrix to ensure there's alignment of who's doing what when. And I think that's one of the issues we've seen is like a gap, not necessarily overlap of scope, but typically gaps in scope. So getting together and putting a roles matrix together on who's doing what at what time for each phase of the project. So it's not just a schedule, it's actually digging into who's doing what on each part of that schedule and clearly defining those roles. I think that's a great way to de-risk your projects. It's a great question, Ryan.
Great, thanks so much. We'll get to any other questions at the end of the presentations. Thank you for your presentation, and we'll move along to our next one. Next, we have Kim Murdock-Timmerman. Kim is the Aftermarket Sales and Service Manager for Unison Solutions. She has been with the company for 13 years, helping customers evaluate their biogas chemistry and finding solutions to meet their requirements. I'll pass the floor over to you, Kim.
Great, thanks so much, Ryan. I'm going to move into kind of the middle of Jeff's project line. So when you're finalizing your design is what we'd like to talk about today. As Ryan said, Unison Solutions is an actual manufacturer of biogas conditioning and upgrading equipment. This is an example of a system we have at our site in Grand Rapids, Michigan. If you could forward the slide, Natalia. We have been US based forever, based in Dubuque, Iowa. And two of our main owners, thank you. Two of our owners decided in November of 2022 to sell the company to their employees. So we've been employee owned. We're steadily growing. We've just added 45,000 more cubic feet or square feet to our facility. And currently we have over 395 biogas systems worldwide. So biogas is our definite focus. Okay, now you can go. Thank you. As we're talking about today, we're going from biogas though to renewable natural gas projects primarily. And so, we've done systems that were outdoors with those enclosures that we saw just a moment ago. This is another system that we have in Lincoln, Nebraska, that's an indoor installation. And these two particular systems happen to be membranes. Next slide. I put up our project map just because it's changing a lot lately. So this is our traditional map, and this includes customers in the municipal area, wastewater treatment plants, landfills, food, industrial digesters. We're getting a lot of ag systems. But what's interesting is in the past, we always had systems where there were a lot of big populated areas. And now it's kind of like our rural customers are able to get in on the activity because we're looking more at the agricultural. So it's been very interesting. Our group has been in places that we've never been before. Western Kansas, in Oklahoma, the Dakotas, Nebraska, western parts of those states. Like I said, it's been a very fun time because all of a sudden it's kind of like everybody's branching out and can get in on it. But like I said, those new opportunities are definitely in some of those smaller populated areas of the country. And next slide, please. So when we're looking at a successful RNG project, folks like we heard Jeff talk about, they're going to look at the big picture and get a concept going. What we like to do is we have to dig into the details, right? So some of the challenges that we've seen have been with determining the inlet gas quality and then what that final specific RNG quality is. RNG is a very, very general term in terms of what tariffs you're actually looking at based on specific pipelines. So that's what I wanted to just dig into a little bit more today. So next slide, please. So we all know biogas is methane and CO2, usually a 60-40 mix. There's always some nitrogen in there, hopefully not a lot, hopefully not a lot of oxygen. The hydrogen sulfide is going to vary depending on your feedstock. And it can be anywhere from non-detect for sites that do some pre-treatment upstream to over 10,000 ppm. So huge range for hydrogen sulfide. And then things like moisture and particulates are present and fairly easy to remove. And then the last category is where we kind of get some hiccups. So siloxanes and other volatile organic compounds. And it's a big group of compounds, primarily those compounds with hydrogen and carbon atoms. But then we've got those other ones. So the siloxanes are a carbon, hydrogen, and silica group. There's different VOCs that include chlorinated VOCs, fluorinated ones, hydroxyl groups, the ketone category. All of those things need to be taken into account. And you can see on our pie there, it's a very small percentage of the overall volume of gas, but it can make a big impact on what you have to do to treat it. So on the next slide, please. Siloxanes is one of the things I wanted to talk about because most sites that have either food waste or agricultural waste come and tell us, well, we don't have siloxanes. And unfortunately, that has not proven out to be the fact. Some sites don't have siloxanes or they're extremely low, but because the number of uses for using siloxanes in industrial equipment, sealants, cleaning materials, there's a very popular compound that's used as an additive to a lot of different things. As that increases, we're seeing siloxanes in almost every biogas sample that we see. Every once in a while we'll get one that has everything below detection, but it's very, very rare. So if you have that in your brain that siloxanes are not going to be an issue, we suggest taking the time to at least test your gas and see what's going on and make sure of that before you choose your system and pull the trigger on something that's not going to meet your final specs. So next slide, please. So when we're doing that inlet biogas testing, this is something that you have to do for your EPA qualifier for your pathway, is do the raw gas testing. It's also done to figure out that final application. And just as a bare minimum, we recommend doing the major gases, siloxane, sulfurs, and then a volatile organic series. If you know what your tariff is specifically from the pipeline, we can expand on that. But this is the test that we like to say, okay, here's your bare minimum. If you have your digester operating, let's start with that. If you don't have your digester operating, obviously we're going to have to make assumptions. But hopefully before you get to that final startup, we're going to be able to look at this and we will have discussed some of the characteristics of your feedstock, and we've made a game plan of how do we get to that point of if we have to adjust treatment, that we can do that based on what equipment was specified. Next slide, please. So this is our pipeline, right? So when we're talking about it, some of the things we just talked about testing are also going to be standards on the pipeline. One of the unique things in the US is that every pipeline tariff is different. And it can be different from between sites that are very close to each other on the same pipeline. Okay, so depending on the timing and when you negotiated your tariff, your set of parameters can vary from your neighbor's set of parameters. And that's always a very difficult concept for people to think about because they're just kind of like, well, it's RNG, it's everybody's pipeline. And that's just not the case. So you really need to look and ask those specific questions. You want an actual list of what compounds need to be tested and what the protocols are, because that's going to be important when you're choosing how to do the testing. The other things you need to look at are things like the interconnect fees. They're going to vary depending on whether it's an interstate pipeline, that's one that goes across state lines, or if it's an intrastate, so within a state. Those fees always come into play. Things like the flow and pressure that's required. Some are very high pressure lines, some use low pressure for their insert. And then there's also the virtual pipeline, which is very popular with a lot of our ag customers, where they're using compression and tube trailers on site, taking it to another tie-in location. So lots of ways to do it, but again, lots of questions to ask. And especially the gas requirements. Like I said, that can make a big difference on your equipment. The other thing to look at affects your ongoing costs. So what RNG monitoring are you going to need? Is it, is some of it going to be online? Some tests cannot be done online. They have to be done in a laboratory. Is it a yearly test? Is it a quarterly test, monthly? All of those things can need to be looked at for your O&M moving forward. All very important. Next slide. So I wanted to just give you an example of what we've seen. Raw got biogas, as we said, the methane, usually around 60 to 70%, the balance being CO2. H2S is all over the place. Siloxanes and VOCs are all over the place. Again, that's based on your waste stream. The example of the natural gas pipeline is just a very general one. And a good portion of the pipelines that we've worked with in the US fall into this category. And then every once in a while, you'll get an anomaly. So the DTE spec on the far right is really it's a very straightforward spec, but the oxygen is the kicker, right? So if you were just thinking, I'm just going to go with the basic natural gas fuel spec, and didn't realize that DTE has a spec of oxygen that's extremely low, that spec alone means a whole nother piece of equipment is going to be required to take your oxygen from the 0.2% coming out of our system down to the 0.0005%. So it can make a big difference. Next slide, please. The other thing you have to look at is, are there specifics? So this is an example of a spec in the Western US, and you can see the very general specs are on the left-hand side, and they're pretty standard. And then this particular pipeline really goes into the details of what you have to test, and this grouping the organics. So for this particular location, there's a fair amount of testing that has to be done. Luckily, it's only done yearly, but it's just one of those examples of, it can vary a lot. You can have, just a quarter of a page of specs that have to be met, or you can have multiple pages of very specific organics and groups of organics. So like I said, don't assume that everything's gonna line up and be the same. So next slide, please. So when we're talking about that DTE spec, this is Grand Rapids again. And we've got the hydrogen sulfide removal vessels on the lower left. This particular site is a municipal wastewater plant. And they've got 2 redundant 400 SCFM systems. So inside those enclosures, we're taking out the moisture and particulates, compressing the gas. Siloxane vessels are at the front. That's another fixed bed media. And then it goes into the CO2 removal, which in this particular system is a membrane based. And then we have a bacteria filter. For the, and this happens to be a 3-pass system that gives you a really high recovery rate for methane. So that helps with your emissions, and it also increases your CI score, which is important when you're doing your EPA pathway. And then for that oxygen spec, they have a completely separate deox system, and that's what you see on the lower right. So you can see that one line in that very simple spec can make a big difference in the amount of equipment that's required. And next slide, please. The other thing to think about, and this is just when you're planning in the planning stages, is where are you going to put everything, right? So typically the H2S vessels will get the best operation out of them if they're close to the digesters. H2S media traditionally likes 100% saturated gas, so you want to keep your pipe run as low as possible. On the other end of the spectrum, the equipment for taking out the moisture and particulates and injecting it into the pipeline, all of that wants to be together as well. It doesn't have to be right next to the digester necessarily, because the piping between those two is not as critical. So it's just something to think about is when you're laying it out. We sometimes have people say, well, we didn't, we thought we just put everything together, which that's fine. But if your injection point's a long ways away, then you have piping costs. So those are just another one of those challenges to just really look at that big picture before you get too far into your project. Next slide, please. I appreciate the invitation. We're always available to help customers at any part of their process. Reach out if we can help you with anything. Thanks, Ryan.
Thanks for your presentation, Kim. On the topic of testing biogas and the parameters you discussed, could you talk maybe a little on what's important when you're choosing a biogas testing lab?
Yep. If you have your tariff, the most important thing is to see if they have any specifications. So if the tariff specifically says, we want you to follow protocol ASTM, whatever it is, or EPA protocol, to know that up front, because when you're getting evaluated by the EPA, it's really nice if everything lines up nicely. So if they want your major gases as an ASTM 1945, if that's the protocol you've used, then there's no question. And it's not that there's not other protocols that will work, but it just makes everything a little easier if you can have everything line up very nicely with what your tariff is. And then for the SLOXANs and VOCs, we like to get that data as low as possible. So we usually recommend a detection limit of 5 parts per billion, and the data needs to be speciated. So we don't want any total siloxanes or total organics. It needs to be by component, because those components all have a different removal rate when we're looking at fixed bed products for taking them out.
Great, thanks, Kim. We'll get to further questions at the end of the presentations. We'll move now to our last presenter, Scott McKay. Scott McKay is a business development advisor with Fournier. He is a wastewater, and environmental science specialist with over 25 years of experience in government, business, and consulting. A graduate of the University of Quebec in Montreal, receiving a BSc and MSc, Scott has assumed leadership positions and managed strategic issues in Canada, the US, and abroad. He advises environmental business leaders in matters of market development and social acceptability. Scott, the floor is yours.
Thank you. So let me share my screen right here. Okay. Well, thank you for the opportunity. Thank you all for taking the time to participate in this webinar. We want to talk about digestate management. So, of course, in RNG plant operations, it is the biogas that is the main topic and the main challenge, but we know that to make the global operations more profitable, there's also opportunities to give value to the byproducts. So basically, the organic material that comes out of the digester, which part of it has been transformed in water and in biogas. So you've got at the end some materials that contains a lot of water, and that has concentrated different nutrients that can have a lot of value if they are treated adequately. So Fournier Industries is a company that was founded in 1960. So I guess that was a good year, because that was also the year I was born. And in the mid 80s, Fournier developed a new type of dewatering of solids liquid separation technology, which is called the rotary press, and they sold their first in 1992, first in the U.S. in early 2000, and there are now over 500 of these machines mostly in wastewater treatment plants, but also more and more in RNG plants. And with interesting fact is that the area that has developed early with us with the RNG plants is in Scandinavian countries, and now there are also in Canada and in the US. So it's a market that is definitely growing. If you consider the dewatering process, so there are different steps once the organic matter has been digested through into the anaerobic digester, has generated its biogas. You need to pull it out, and in order to remove the water out of it, there's a few steps, usually coagulant, then flocculant is added. Both those two different chemicals have different goals, but at the end, they need to be blended in a flocculation tank that will allow the solids to agglomerate together and be easily separated in the next step, which is being dewatered. Of course, at Fournier we use the rotary press, but dewatering is typically done in many places by screw presses, centrifuges, and the rotary press is a little bit the new kid down the block. Separating solids from the liquid then allows you've got basically two products, the digestate and the filtrate. So the digestate typically would go to land application, even though that's not always possible. And the liquid filtrate can be used directly, or there are different processes to remove or extract and concentrate the nutrients that are in the liquid phase. Of course, whenever on smaller installations or agricultural installations will, if you can use just the liquid digestate without having to dewater it, that of course that's always the first option, but unfortunately it's not always possible. In many cases, the agricultural land around the RNG plant can take only so much material, so you would need to truck it out, and then transportation cost becomes too high. You're transporting basically water. So in that case, it's essential to dewater your liquid digestate, and also it's not always possible to land apply because of different components or different regulations that, for example, very recently, state of Maine has adopted a moratorium on land application of biosolids. So even though because of PFAS concentrations, and of course the anaerobic digestion doesn't destroy PFAS, and in that case, well, either the solid digested would need to go to landfill or to another process that does destroy PFAS, such as pyrolysis. This is what the solid looks like coming out of a rotary press. So basically, that will be probably around 35%, 30 to 35% solid content. It has the texture, I would say, we call it also a cake. It has pretty much a texture of a brownie. And the filtrate then is a fairly clear and clean liquid, but it does still contain a large quantity or large quantity of different nutrients, typically a lot of nitrogen that will be mostly in the form of ammonia, so which gives it a pretty strong smell, but that can be concentrated later. One important factor, or one very important factor, when you will be at the end land applying the solids, is the odor. Especially when there are biosolids from wastewater plants involved, the odor can build up over time. So there's different ways to reduce them. In the past, biosolids, for example, have been mixed, blended with lime, fairly large quantities of lime, but that's not well suited for all the lands. It also increases the weight. It has a cost to it, and when it's coming out of an anaerobic digester, it's been stabilized, and that shouldn't be necessary to add lime. What has been it's been found that different dewatering technologies, or some dewatering technologies, can actually generate odors, and there have been some studies that have demonstrated that the liberation of certain type of proteins are precursors of odor, because they become food for the type of bacteria that generates organo sulfur compounds. In a comparative trial, a side-by-side trial, the total volatile organic sulfur compounds that have been identified as being a major source of odors, of foul odors, have been measured during the storage time, and it's been demonstrated that materials coming out of a high-speed centrifuge generated fairly large concentrations of these compounds, while material that had been dewatered through a rotary press had very little, if none, or close to zero, or non-detectable concentrations of this type of compound. It's also important to have a good solid liquid separation, good dewatering to give value to, or give more value to the liquid and solid byproduct. So as I mentioned earlier, higher dryness will reduce the transportation costs, but they also, when it is dry enough, can be used, sold to companies that sell or manufacture and sell soil amendments. So they will also require a certain level of dryness, and these materials can also be dried. There's different locations that dry them and sell them as pellets. In that case, of course, you want to reduce the amount of water that will be that you will have to evaporate through drying, because that it's very takes a lot of energy to evaporate water. And we mentioned the odors. On the liquid stage, well, having a clean liquid digestate will allow, in some cases, some locations will want to use that water for irrigation. So since there are nutrients in it, it's called fertigation. So you want a clean filtrate in order not to clog the nozzles that will spread that irrigation. You don't want to clog your irrigation system. And if you are recuperating nutrients from different type of concentration systems, or there's also some evaporation systems that of course will if there's too much solids in that liquid, that will eventually reduce the efficiency of those treatments. There's a lot of different costs involved in dewatering, so I won't go through in detail through all of them, but it's been found that in the cost of dewatering, about 50% is related to chemical usage, especially polymers are very costly. So it's also important when you select your dewatering equipment to make sure that you select an equipment that will use the less polymer possible. So in conclusion, dewatering it can be important to reduce the volume, facilitate the management of this material, and generate valuable byproducts. So it's important not to overlook this step, even though, of course, the biogas is the focal point in your design and eventually your operations, but good quality products will be well accepted on the market, and will also contribute to profitability of your operations. So thank you so much for your time.
Great, thanks for your presentation, Scott. Before we go to the broader Q&A, we'll just ask a quick question from the audience here. So from Richard, water recovery and reuse is becoming a key element of processing. What is the typical processing method used to reduce salts and other components in the liquid fractions of digestate?
To reduce the salt?
Yes, reduce the salts.
Well, actually, we everything you want to reduce in the digestate needs to be reduced at the head of the plant in the feedstock management. If the question is about recuperating salts in the liquid phase, well, our company are not involved in those types of processes, but what we know from our customers is that they appreciate having a filtrate that is clean, or that when the solid to liquid separation is efficient, or what we call the solids capture rate is very high, then the only almost only thing that is left in the liquid phase are salts or nutrients in salts that can be recuperated, and that can, for example, be taken out in the form of ammonia sulfate, and that can be used as a fertilizer.
Great. Thanks, Scott. We had 3 great presentations today: project challenges and opportunities with Jeff from Mead&Hunt, specific challenges of upgrading projects by Kim with Unison, and digestate treatment opportunities and challenges by Scott with Fournier. So opening it up to all of our presenters, I wonder, when looking at the biogas and RNG market today, what do you see as emerging territories that are gearing up for new biogas plants, or do you think it will still be mainly the same territories from the past few years?
Well, I think Kim had an interesting map.
Yeah, as far as, are you asking specifically locations, Ryan? Is that your?
Not specific locations, more like states that you think, like, are they going to be the same states we've seen with high development in the last few years, or are there any that are up and coming that you think will be big markets soon that maybe are under their current potential?
I think there's going to be a bunch of scattered ones. Like I said, any place where there's large agricultural facilities, and where there's even small agricultural facilities that have decided to work together and either combine their waste or have a central treatment plant. Like I said, that's what we're seeing, is that it's not in one location at all. It's but it's almost all in rural areas. So away from the big cities and out into the countryside is what we're seeing.
Yes, well, we're not involved in as much biogas projects than the 2 other presenters, because we're a lot in wastewater plants, and of course those are pretty they're spread out they're everywhere, but yeah, the specifically like we've seen in the past, pig manure projects, these seem to have left place to what we're seeing now are more dairy manure projects whenever it's agriculture is involved. So I don't know, possibly these location of projects are probably also pretty linked to the availability of subsidies, or the possibility to have easier access to pipeline distribution, because I think Kim showed very thoroughly how complex can be injection in pipelines. And of course, if the pipeline is far, then there are more costs associated and permitting and such. One of our customers they're located, just very lucky to be just there's gas pipeline going directly on their property. So that, that was an easy one to figure out, even though it's location is just one item as Kim showed, but it at least that makes it a little bit more attractive.
Thanks, Scott. Okay, I can jump into questions from the audience. I think this one is directed more towards Jeff. Can you provide thoughts on construction timelines today and how have they trended?
Sure. So, I mean, I think maybe that you're trying to answer the question about available labor resources for construction, maybe is in the timeline for supply chain, and it's definitely improved over the past year. We are having subcontractors contact us asking about future projects. So they're trying to identify 2025 projects, so they're not fully booked yet as far as their workload. So that is good. That can help drive down schedule, drive down pricing by having more available resources from the labor standpoint. And then also on the supply chain as well, we've seen improvements on delivery times across the board. The hangups were the gas upgrading equipment and the electrical switchgear, and we've seen some improvements in those over the past couple months as well. So everything I'd say is trending to help improve our project delivery.
Thanks. Another question from the audience is on how to make projects at very small farms more feasible. In your experience, what is the smallest project you've worked with up to date?
For Unison with the RNG market, it's about 100 SCFM is where you can start having it be feasible. If it's smaller than that, then it makes it a little bit harder. But we do have 100 SCFM systems that are operational and have been having good results, and just a little bit longer payback because of the lower flow, but it's definitely doable.
Thanks. Jeff, Scott, do either of you want to jump in on that or no? Okay. Sorry, just grabbing another question from the audience. Are there any thoughts on project CapEx that you guys can weigh in on the trends? Are we seeing, as more systems come out, there are best practices that are kind of bringing CapExes down, or with supply chain constraints, or CapEx is increasing?
I think, getting modularity is a key to that. So, looking at prefabricated solutions can minimize the cost of installation on the site. So that's one way to do it. And then actually trying to get from a scaling perspective, looking at the scale and sizing of the equipment for best fit. And that gets into then the question of redundancy and uptime. So you may be trading CapEx for more OpEx if you're trying to cut costs, right? So there's always that trade-off. I'm sure Kim sees that all the time when they're evaluating their equipment selections for projects as well. But that's the question we get asked a lot, or actually put that back to our owners of how do you want to spend your money? Less upfront, maybe more operations and maintenance on the backside.
Yeah, I'd agree with that, because we see too often people putting maybe a little bit, well, in our perspective anyway, too much focus on the CapEx, and you know, not looking at what will be the operation cost in the future. And of course, if you need to dewater your digestate to do that liquid solid separation, and if it does require using chemicals, and you've got or you know, all the operation and maintenance around that equipment, then you know, you're probably better off putting a little bit more money up front and saving yourself a lot of headaches and dollar signs in the future when you'll be operating. And making sure that you also have byproducts that are quality products that you will find some customers on the market to buy them, while you know, like all the feedstock management up front of the digester. You know, I think it's I've seen some customers that have had some bad surprises. You know, have either some type of buildup in the digester because they didn't have efficient enough removal of sand and silt or floating materials, and of course that can also impact the quality of the outgoing product, and especially if you want to land apply it, there are all sorts of regulations, so you got to be careful, and it's probably not a good idea to try to find cheaper solutions. So yeah, the trade-off between CapEx and OpEx, you got to be careful about that.
Of course. Thanks, Scott. So that concludes our time today. As a reminder, the webinar recording will be shared with our participants next week. If we were unable to get to your questions, we'll share them with our presenters and invite them to send a response to the question via the Biogas community. We invite everyone to join us on the Biogas community platform to stay up to date with content from our US Country Focus Month and to participate in June's Country Focus Month on the UK and Benelux markets. I would like to thank everyone for taking the time to join us today. And of course, thank our presenters, Jeff VanVoorhis from Mead&Hunt, Kim Murdock-Timmerman from Unison Solutions, and Scott McKay from Fournier. Thanks, everyone.
Thank you.